So again, a pyramid is a geometric solid with one base that is a polygon, and all of its lateral faces are triangles. Okay, no matter what the shape of the base is, whatever polygon that base is, all of your lateral faces will be triangles in every pyramid. What's the difference between a pyramid and a prism? A prism has how many bases? Two. How many does a pyramid have? One. Okay. The vertex is the intersection of all lateral faces. There is a vertex, one and only vertex. It is the intersection of all of your lateral faces. Okay. The altitude is a perpendicular segment from the vertex to the base. We talked about this yesterday, like the axis. Oh, come on. It's not wanting to. This bottom piece is not right. Anyway, the altitude is inside of your pyramid. It goes from the vertex to the center of your base. Everybody see that? Follow. Look at my altitude. You see where it is? See how it's inside my triangle or inside my pyramid? That is the height, yes. Your altitude and your height mean the same thing. But in a pyramid, Melvin, are you throwing trash across the room?
No.
Are you throwing something across the room?
No, you're on this, now on this, and you try
Okay, well, how about focus on me? I want all the attention right now. My height is inside my pyramid, touching the vertex and touching the center of the base. Okay, a regular pyramid is going to be what we are dealing with, which means all of the bases are regular polygons, like a square or an equilateral triangle, or if it's a hexagon, it's a regular hexagon. We know how to find area of regular hexagons with the apothem and stuff, right? Okay, look at my base. Look at my base. If I drew a segment right here, what would that segment be called in a regular polygon from the center to the edge? Dark length and A.
Altitude.
Nope. The apothem. Okay. Here on my base, it goes from the center to the edge is your apothem. Now we are going to have to use that here in just a few minutes, but we'll talk about it on the next slide. But in a regular pyramid, all of my lateral edges are congruent. So the length of these are all congruent, right? It is on any regular polygon going from the center of it perpendicular to a side. The radius goes to the corner. Okay. All of your lateral faces are isosceles triangles, okay? Because these two sides are congruent, that makes them isosceles triangles. And the altitude goes through the center of the base, which is what I was just telling you before. All right? Now, one little other thing that's a side note that's written under here is pyramids are named by their bases, okay? This would be what kind of pyramid? Square pyramid? It would be a square pyramid, yes. And that would be a square pyramid. Where's my other one? Oh, there it is. What kind of pyramid would this be? This is a triangular pyramid. Its base is a regular triangle, which makes it an equilateral triangle, right?
Right.
Okay. I don't have any other pyramids in here. Now, this is something else that is slightly different about my pyramid, Sebastian. You should be paying attention. Our slant height. The slant height comes from the vertex and it goes down perpendicular on one of your lateral faces. It is not inside of my pyramid, it is on the edge, and it is a slant height. Okay? It says memorize this, that little triangle. It is in all of our regular polygons. Okay, now I want you to focus on what I'm showing you here for just a second. Oh, gosh. So that little triangle over here that has a capital H, that capital H is the altitude, okay, where my finger is. The slanted or the curved italicized L, that's my slant height that goes along the edge of my pyramid. And then that little A stands for, what did we call that segment from the center? Yeah. So I've got this little triangle, that right triangle here. It is technically inside of my pyramid like this. Okay, everybody look at this little triangle that I have. The one that we're wanting you to memorize, the height, the slant height, and the apothem. It's inside of my pyramid like this. Okay? So you've got to imagine three-dimensionally where it is. You see this? This is the little triangle that you're going to have to memorize. The height, the slant height, and the apothem. And it's actually inside of our pyramid. Everybody good with that? Huh? No. That's me trying to draw a three-dimensional, but I can show it to you easier here. Yes, you need to draw the easy one because you need to memorize that.
What does the A stand for? The apple?
Yes. This is the triangle you need to memorize. Okay, that is what we are going to be using when we need to find certain parts of our pyramid for our formula. And I'm just going to write what everything means. The capital H is the height of the pyramid, which is the same thing as the altitude. The italicized L, or the lowercase l, that is a little slanted usually, which is italicized, that is called my slant height. And then the A is the apothem of your regular base, whatever that regular base is. And what kind of triangle do you notice it is? A right triangle. So we're probably going to have to use the what? Pythagorean theorem. And you don't always have to use it. Sometimes I'll give you everything you need. Sometimes you're going to have to find bits and pieces of it. Okay. We're going to talk about the formula for lateral area, and we're going to talk about the formula for surface area for these pyramids. Is everybody ready? Okay, so lateral area is 1/2 P times L. What do you think P stands for? Perimeter. Okay. L is my slant height. We could also write it as the perimeter times the slant height divided by 2. Anytime you multiply something by 1/2, you can always divide it by 2, and that would give you the same thing. And then your surface area is your lateral area plus how many bases does a pyramid have? Just 1, right? Prisms have 2, pyramids have 1. So this is just my lateral area plus this big B represents the area of the base, and that is going to change depending on what shape your base is. Okay, we're going to start with a relatively simple one, and then we'll get to the harder ones where we have to find some stuff. Is everybody ready? Okay, I'm going to write the formulas up on the board so you have them easily seen as we go through these. The first things we have to think about is, do we know enough to find the perimeter of the base? Yeah. And do we know enough, or do we have the slant height? Okay, and then also, do we know enough to find the area of the base? If you can't draw the three-dimensional, it's okay. Just do the best you can. Those are kind of hard to draw. What I would recommend doing is focusing on the base first. Okay, what shape is my base? It is a square because these are regular polygons. It is a quadrilateral, so that means it is a square. And I can't draw that pyramid very well, but I can draw a square. Do I know the length of one of my sides of my square? Yeah. It's 6, which means every other side is also 6. Okay. Now, let's find, first of all, the perimeter. If one side is 6 and there are 4 sides, what is the perimeter going to be? 24. And then let's find the area of the base. 36. One side times the other, right? Is everybody okay so far? I just focused on the base first. then we can go back to our three-dimensional figure. I got the perimeter of the base and I've got the area of the base. The only other thing I need, according to my formulas, is the slant height. Is the slant height given to me in this picture? Yes, and what is the slant height? 8. Okay, so let's start with our lateral area. Lateral area is going to be my perimeter, whoops, times my slant height divided by 2. What did we say the perimeter was? 24. Times what is the slant height that's given? 8. And divided by 2.
192. Yeah, divided by 2 is like 90. Yeah, 192.
96. So my lateral area is 96. 24 times 8 divided by 2. And then for my surface area, we take that same lateral area, that 96, and we add the area of the base. There is only one base, so we don't need to double it. What is the area of the base here? 36. So my total surface area is going to be 132. Okay, so lateral area is 96, surface area is 132. So if I have a simple pyramid like a square pyramid, and I'm given the slant height, they're really not that hard. It's when we're not given everything we need and we have to figure out what parts to find and how to find them. That's when these pyramids get a little trickier. Everybody ready?
Yeah.
Yeah.
Again, if you're trying to draw these pyramids, they're the easiest way I can say to draw them is kind of draw like this, and then you do your base, and then do your dotted stuff from behind.
Yeah.
That to me is the easiest way to draw it. But then it changes if the base is not a square. It changes into a different way.
Are there like right pyramids? Like with the
With the oblique in the right?
yeah.
Yeah, we're going to just deal with all right ones. We won't have any slanted ones because then that changes your whole triangle with the height and the slant height and the apothem. Everything we're sticking to is right, meaning they're standing straight up. Good? Okay. Okay, I want you to take a second and draw this picture. What shape is my base?
A square.
A square. So we're going to focus on the base only for just a minute. Okay, so I'm going to draw myself a square. Now, the only piece or the only length I know in that base is the what? The apothem. That apothem goes from the center and it goes perpendicular to a side, right? So that's what I know. So far, so good? Does everybody understand that I just pulled that base off and wrote 3 in there? All right, I have to find the perimeter and I also have to find the area, but in order to find the perimeter and or the area, I have to know the length of one side, correct?
Right.
Okay. What do you think my apothem is in reference to my side? Half of it, right? The apothem goes from the center to the edge, so if I went from the center to the other edge, that would be another 3, right?
Right.
Which means the length of my whole thing is 6. Okay, so one side is 6, which means every side is 6. Okay, so in a square base, your apothem is half the length of one of the sides. So what's the perimeter going to be?
24.
24. And the area is 36. Do I have everything I need to find my lateral area? What else do I need? The slant height. Do I have the slant height? No. Okay, we need to focus on this triangle right here. Okay, it is a right triangle, right?
Yes.
I know 2 of the lengths of my sides, which means I can do the Pythagorean theorem to find that one, so take a minute and do that. So you need to use that right triangle, the one that we memorized, the height, which is 4, the apothem, which is 3, and you need to figure out what your slant height is. Which one of those is C? 4, 3, or X? X. Okay, so we're going to go 4 squared plus 3 squared equals, bless you. Or you could say 3 squared plus 4 squared. And then, so what is X going to be, or our slant height? 5. Now, do we have enough to find everything? Yes. All right, so let's work on our lateral area. It is my perimeter, which is 24, times 5, my slant height, divided by 2. You get 60. And then my surface area is that lateral area, plus what did I say the area of the base was? 36, and that's going to give me 96. Okay, so sometimes we have to use that right triangle inside to help us figure things out. It can. Huh? Maybe. Everybody good? Go ahead. The base is just, I just drew this bottom part separately off to the side so I could focus on finding the perimeter and the area of it. Okay, are you asking me how I got this base? Oh, okay, I'm sorry. I was like, I just looked at the shape. I thought you meant how did I get the square? For area of a square, the area of a square is just your side squared, or side times side. 6 times 6 gives me 36. Okay, like a rectangle length times width. Does that make sense? Okay. Everybody ready?
Yeah.
Try this one. Hold on, let me see if I got any more. Okay. No, I don't. Okay. Try that one. Again, I don't know that I can draw a very good hexagonal pyramid, but I can draw a hexagon. So we're going to focus on this base that is a hexagon. Okay. So take a minute and draw yourself a hexagon. So far, so good? Okay. Now it says the lateral area and surface area of a regular hexagonal pyramid with a base edge of 4. So that means one of these sides is 4, right? Mm-hmm. And the slant height. Well, the slant height is in my pyramid, so I'm going to hold off on that for just a minute. What 2 things do I need to know about the space? I need to know its perimeter. Okay. If one side is 4, how many sides does a hexagon have? 6, which would give me a perimeter of 24. Mm-hmm. But I also need to know the area of that base, right? We don't have a formula for any old hexagon, do we? But we do have a formula for a regular hexagon. Think about that. It is apothem times perimeter divided by 2. Okay, so I need to know the apothem, I need to know the perimeter, and then I need to divide that by 2. Which one of those do I already have?
The perimeter.
I do have the perimeter. What piece did I say we needed to memorize that involved the apothem of my pyramid? The triangle, right?
Yeah.
Okay. So the triangle. What is my slant height?
6.
Whoops. Started to write the wrong number. Do I know the height of my pyramid? No. Do I know the apothem? No. So let's think back to how we found all of that information in a hexagon. Remember we drew our triangles? What angle was at the top in a hexagon? Think your central angle is 360 divided by 6, right?
Right.
Which would be, it's 60, but you used how much of it?
30.
Half. So this is a 30, 60, 90 triangle, which means I need to find my apothem. Quick question, what is this length right here?
That's 1.
No, but not in my reference triangle. It's 2 here, right?
Yeah.
Okay. All right, so let me draw my reference triangle then. That is 1. That is the square root of 3. That is 2. Is everybody following what we're doing? It's just, you got to remember how to find that. Okay, I'm stopping. Tell me where I lost you.
I'm just.
Okay. I'll wait and let everybody have a minute to catch up. So we have to just remember everything that you need in order to find the lateral area and the surface area. We can easily find the perimeter because we knew the length of a side. Finding the area of this base, because it is a regular hexagon, is a little bit more challenging because we have to remember how we did that 2 chapters ago, right? So it's a little bit harder just because we've got to bring some stuff back. So in order to find what the angle is, you take your 360 divided by the number of sides, which is 6. So 360 divided by 6 gives me 60. But we only want half of that for our triangle inside of our regular hexagon. We're talking about 2 separate triangles here. Okay, now I've put in my information that I know in the hexagon, and then I've drawn my reference triangle. So let's figure out what our apothem is. I'm going to come over here and do it. What is A in the same place as? Square root of 3. And then the only other side I know in the triangle inside my hexagon is a 2, and it is in the same place as 1. And so if I cross multiply, I get my apothem is equal to just 2 square roots of 3. Is that all I need to know? Yeah, right? Okay. So I don't even really need to use this triangle over here, do I? No. If I had my height, I could, but we were able to just use the hexagon. So for the area of the base, it is my apothem, which is 2 square roots of 3, times, what did we say the perimeter was? 24. And then we're going to divide that by 2. 2 times 24 is 48. Divided by 2 goes back to 24. So the area of my base is 24 square roots of 3. Now you should have everything we need to find the to find the lateral area and to find the surface area, because we do know the slant height, right?
Right.
So go ahead, find your lateral area and your surface area. What was your question? What, the apothem and perimeter? It's any regular polygon, yes. But you have to be told it's a regular polygon. Find your lateral area now that we have everything we need, and then find your surface area. Leave it in radical form since we have a radical involved here. Don't give me any decimal values.
Can you add a radical to the regular number?
No. Lateral area is my perimeter times my slant height divided by 2. What is our perimeter? 24. What did they tell us our slant height was? 6. I'm going to divide that by 2, which gives me a lateral area of 72. And then my surface area is my lateral area 72 plus my area of my base, which we said was 24 square roots of 3. Can I actually combine those together? No, they are not like terms, so I'm going to leave my answer just like that. Lateral area is 72. Surface area is going to be 72 plus 24 square roots of 3.